The terms machine learning and artificial intelligence are often used interchangeably, but it's important to point out that machine learning is a specific subset of AI and really underpins many of the sophisticated AI models that we see today. And the term machine learning itself can encompass a wide variety of different scenarios, use cases, and applications. So we may see it used as part of data mining, we may see different machine learning algorithms or machine learning used to refine algorithms, in classification models, in things such as neural networks, deep learning systems, generative AI, and other autonomous systems such as those used in factories, for example. Now, in terms of the evolution of machine learning, we trace its journey alongside that of AI, since they are such closely interrelated concepts. Now, in 1957, Frank Rosenblatt, a computer scientist, came up with the idea of the perceptron. And this would really lay the foundation for a lot of the later work in much more recent times on things such as neural networks, for example. 1959 saw the first documented use of machine learning in a game-like scenario. So Arthur Samuel created a machine learning solution that allowed it to play the game of checkers. Now, after that, we saw what's known as the AI winter, where we really saw a decline in the funding and the time that was allocated to projects involving machine learning and AI. And really, one of the key reasons for this is that although some of the foundations work would prove to be absolutely sound, at the time, the technology was a limiting factor. So it wouldn't be until much later that technology advanced enough to allow these initial ideas from pioneers such as Frank Rosenblatt and Arthur Samuel to effectively be proven correct. Now, the 1980s saw the further development of neural networks and deep learning. The 90s saw the introduction of developments such as support vector machines that we can see here, which again is all about the improvement and refinement in terms of how machine learning worked. The 2000s saw the emergence of lots of different concepts, including natural language processing and things such as computer vision, where we're able to actually classify elements of images or of video, for example. And then moving really into the 2020s and the emergence of generative AI, which has become a fundamental part of our everyday lives. And of course, we'll use machine learning as part of the training process. And indeed, we see machine learning in lots and lots of different applications, some of which we can see here. So things such as image and speech recognition, predictive analytics, something that we see a lot in telecommunication networks, for example. Autonomous vehicles, so machine learning can be used to allow autonomous vehicles to make decisions related to their surroundings, to classify the elements that they see in the road, from things such as street signs through to pedestrians and other vehicles. Healthcare, so machine learning can be used to diagnose lots and lots of different diseases such as cancer, for example, and it can do so in a much more accurate and faster way than human would be able to. So we see this in things such as MRI scans, such as X-rays, for example. Machine learning can be used to make much faster and more accurate decisions. We've got finance, so machine learning can be used to predict patterns, for example, in the stock market. Cybersecurity, so machine learning and artificial intelligence systems can run in networks and they can look out for anomalous situations, for example, and take action against them. And then energy grid, again, we've got this adaptability, this dynamic ability to be able to adapt to different conditions and adjust parameters. So this is the sort of thing we would see in energy grids, but we also see this in computer networks and other types of network as well. So finally, we can take a look at some different methods of machine learning. So we've got supervised learning. So what we're referring to here is the training process for a machine learning model. So this is where we feed it potentially some real world data, some existing data that we use to then train the machine learning model. So with supervised learning, we feed it labeled examples. Now, the problem with this is we need a human to actually label all these different examples. So when we talked about computer vision and autonomous vehicles earlier, this might be used here. So we might label lots and lots of different examples of pedestrians, cyclists, other vehicles, street furniture such as street signs, and lighting, for example. So this can be a time-consuming and expensive process, but the benefit that we have here is that we're able to use known input and output pairs, which in theory should make the model more accurate and make it able to make predictions on new unseen data. Now, with semi-supervised, as the name suggests, we utilise a small amount of labelled data, but we combine this with a larger amount of unlabelled data during training. Now, the reason that we do this is to save money and to save time. So as we mentioned, supervised learning can be extremely time consuming and extremely expensive. So semi-supervised learning, particularly with more modern machine learning algorithms, mean that we can use less labelled data. We've got unsupervised learning, and as you might have guessed, this involves providing the machine learning model with unlabelled data, and we use lots of different methods to identify different patterns that may be intrinsic to the data itself and extrapolate from those patterns to create new data. And finally, we have reinforcement learning. Now, if you think of our game-like scenario, so a game like checkers or chess, for example, we can train a machine learning model to take the most optimum move, and we do this by continuously providing feedback on moves that the model makes. So when the move makes a less optimum or a poor move, it's punished, and the punishment will depend on how poor the move is potentially, or it's rewarded for the quality of the move. And the idea here is that over time, in much the same way that a human would learn, it learns through trial and error, and ultimately it evolves to always take the most optimum move in a given scenario. So to summarise then, machine learning is a key component of most AI systems, particularly in the training, the evaluation and the refinement phase.